So, so good evening. So the topic which I have taken is the binary search tree topic, and I will be discussing about the standard questions on the binary search tree, and what is a binary search tree, and the binary what is a binary search tree. So first of all, we will talk about what is a tree. A tree is basically a connected components which are trees are basically connected components, and every parent can contain more than one child or not any child. For example, if you can see this, it is a connected component. Like you can see 40 is connected to 30th node, 40 is connected to 50th node, 50 is connected, so it is a connected, highly connected component. And the property of tree is, if there are n nodes out there, then the edges, these things, these things are called edges, and this is called root, and the nodes which doesn't contain any child are called as leaf node. These are the anagrams, or we can say the properties of binary search tree. So if a if a s- if a tree contain n nodes, then there are n minus 1 edges out there. So you have know that if there are n edges, then there can be n minus 1. If there are n nodes, sorry, then there can be n minus 1 edges in a tree. So what is basically a binary search tree? So we will talk about what is a binary tree. So binary tree contain only two child nodes. Every parent will contain only two child nodes only. More, it will not contain more than two child nodes, as you can tell. So a binary search tree contain at more at most two child nodes. We can say that. So as you can see, this root contain two child nodes only, not more than that. And this node contain and not any child nodes, no child nodes. So we will start to what is a binary search tree then. A binary search tree is basically a tree in which it's every parent's leftmost child's this child's every parent leftmost child will contain value less than the leaf less than the parent node value, and every rightmost child will contain the values greater than the parent node. As you can see here, in the left, if the left in the leftmost child nodes, as you can see, 30 is the leftmost child node, 25 is the leftmost child, 35. So every value will contain less than the parent's value. You can see 30 is less than 40, 25 is less than 40, 35 is less than 40. And when you came across the rightmost childs, you can see that 50 is greater than 40, 45 is greater than, and 40, 60 is greater than 40. So it's the this is this is called a binary search tree, and this thing segregate it from the binary tree. This property segregate it from the binary tree. So the things which we have not till now is, a binary tree contains only or not more than two nodes. Every parent will contain not more than two nodes, and a binary tree contain n nodes, so its edges will be n minus 1. So these are the properties which we have grasped till now. And then, and after that, so so there are multiple methods. So to make a binary tree, Then, so we will discuss about how to make a binary search tree. So we will start coding out. So a binary tree contain a node. So a node contain, so at every node, so this is called a node. So every node contain the address of the leftmost value and the rightmost value, and it also contain a value in it. So to represent it, we will using a class. So we would be using a class. So first of all, to make a node, we will using a class. Then we will make a public, all the value public. So it would contain a value node, node star x, left left address, and then this would contain the right address. Got it? So this is representing the value. So x is representing the value here, as you can see. Sorry, value. This is representing the value which contain the node. Left representing the leftmost uh, address and rightmost address. So we have made a node. Then we will make how to make a binary search tree. So how to make a, so we will start with binary search tree to make it. So node star, it will return a node. So first of all, how to make a binary search tree. So if, for example, if we have given values like 1, 2, this is a multiple values which we have given, and from this value, if we have told to make a binary search tree, so starting from it, so first of all, first thing is, we have there is not a new root node out there. If we iterate on this array, so there isn't any binary tree which have been made. So we will make a root node. This would be a root node and its value would be 1. And we initialize the leftmost and rightmost value to be null at this point. Null. Null. And after we iterate on 2, then we would be seeing, so we will go to the so we will be seeing, is the root less than 2? No. Is the root less than 2? Is the root less than 2? Yeah. 1 is less than 2. So this means that, see, 2 is greater than 2. So we would make a pointer here. 2 would be made here. And then we will iterate on 3. And this is our root node. This would be our root node. Okay. Then is, so we will start from root. Is 1 less than 3? Yes. So we will go to the rightmost. Is 2 less than 3? Yeah. So we will go to the rightmost, and the rightmost doesn't contain anything. So we'll put here a node 3. And then we will revert back, and we return our root from here. So it is similar to a backtracking thing. And whenever we will iterate on 4, then we will again check if the number is less than 1, yeah. If the number is less than 2, yeah. If the number is less than 3, yeah. And we do, yeah. We'll put here 4, and then we will revert back. We will write how this reverting back happens, how this thing. So I am giving a brief overview of it at this point of time. See?